Hey, thanks for checking out my video. Frater Kris here from the YouTube channel Sabrosa. Today I wanted to talk about the art of distillation. This will be the first video in a three-part series. Here in the first video, I'm going to go over setting up a fractional distillation apparatus. We're going to talk about the concepts of simple distillation, fractional distillation, short path distillation, and vacuum distillation. So we'll discuss these concepts from both a chemistry and an alchemical perspective. In the second video, we will actually perform our distillation, and we'll talk about how to keep good notes and how to use a pressure temperature nomograph to calculate the actual temperature of our distillation. I'll show you what that chart looks like, and we'll also talk about the concept of molecular distillation, or separating out different molecules based on their different boiling points. In the third video, we'll remove our distillate and we'll transfer it from our receiving flask here on our distillation apparatus. We'll transfer it into some labeled canning jars, and we'll clean up all the glassware, and we'll get it ready for our next distillation. So the third video will be about removing the distillate and doing the cleanup. So to begin the first video, I'm going to disassemble my still here, and I will have the pieces laid out on the counter, and then I will go through with you the reassembling, and we'll discuss each piece and its function. We'll put the vacuum grease on all the joints and some Teflon tape on the smaller joints here, and we'll fill up our chiller bucket here with some ice and some water, and we'll also put some dry ice in our cold trap, around the bottom of our cold trap. Here in the first video, I'm going to discuss the art of distillation as it relates to alchemy and to chemistry, where it falls into the alchemical process of transmutation and the 7 stages of alchemy. We'll go over simple distillation and how that differs from fractional distillation. We'll talk about the concept of short path distillation, where the distillate just travels a very short distance. And we'll also talk about vacuum distillation and how you can use much lower temperatures when you're using vacuum distillation, and by using lower temperatures, then you'll be degrading your distillate less, or you'll be degrading your material less. Less damage is done to the material. So we'll get this completely set up, and then video number 2 will begin with loading our material into our flask, and that'll take us through the entire process. So the purpose of this video is to help aspiring chemists and alchemists to help familiarize themselves with these concepts and equipment. And another purpose for this video will be to get some feedback from more experienced chemists and alchemists on how I can improve my distillation technique. I've literally watched 100 videos at least about short path distillation, vacuum distillation, and I've noticed that in the comments there's a lot of name calling and ego tripping. So I just wanted to remind everybody, before you leave a comment, let's remember to be kind to each other and keep your comments on the level. So I'm going to go ahead and disassemble my still setup here, and then we'll reassemble it together. We'll go through all the names of the different pieces and how they work together, and that'll be the first video. And then on the second video, we'll actually run our material. So thanks again for checking out my video, and let's get started. To begin our setup, we'll start with our large round bottom flask. So in this case, we'll be using a 2-liter round bottom flask from Steamroller Extractions. To keep the glassware clean, I like to use a 99% isopropyl alcohol, and you can find this at your local hardware store. I just pour a little bit in a clean spray bottle, and I use my spray bottle to spray out each of the pieces as we go. So we're going to make sure that all the glassware is clean, and we're also going to make sure that all the joints are properly lubricated with our high vacuum grease. So So we can just grab our round bottom flask. You want to be very careful with your glassware not to do anything dangerous, and we can just start with spraying some alcohol in here. And the reason for the 99% alcohol is it will dry 100% clear. So just spray a little bit of that in there, and that'll clean this guy up. And we'll set our round bottom flask into our heating mantle. The next piece we'll add is going to be our distillation column, or our condenser. And this guy will sit right in here like this. It's important that you keep track of where your other input is. You may wish to use a funnel as you're putting in your material, and depending on which material you run, you may decide that you want to add your material first. If it's a liquid, you probably want to add the material first before you build your apparatus. If it's a oil or something more thick that you might be using a heat gun and a funnel, then you probably don't need to put the liquid material in here first. So to put our distillation head on here, we're going to get some of this Dow Corning high vacuum grease, and we're going to put a little bit of this on each of our joints. This says good lubricating and sealing ability, low volatility, excellent resistance to water, chemicals, high and low temperatures. So this is one of the best products that you can use for this, and it's not cheap, but it's a very high quality product, and you really don't need a whole lot. So I just smear a little bit around like this. You just want to use the very top of the joint. You don't need to lubricate the whole joint, just the top area. And then as we place this joint in there, we'll turn it a couple of times and watch it make a seal. So we'll pull out my funnel here, and we'll take our distillation head, and this guy will sit in here just like this. And as you put a little pressure and you turn it a couple of times, you'll be able to see that seal right there. And now you've created that seal. And the next thing we'll do is clip that piece together. This is called a Keck clip, and these are 2440 connections. This is a 2440 Keck clip. So I'll take my Keck clip and I'll put him right here, and I want to make sure that I've got enough room for this guy over here. So when it comes time to add the material, I'm ready to go. The next piece that we'll add will be what's called a receiving cowl. And this is our receiving cowl here. The three receiving flasks are going to attach here, and our vacuum line is going to attach here. So again, the same thing. We're going to take the male connection, which is this guy here. He's already got some lubrication on him, and again you can see that seal as you push and you turn. You can see that seal is become clear through there, and you know that you have a good seal. And then we'll take another one of our Keck clips and we'll put him here. Now we'll take some of our vacuum grease and we'll put a little bit on each of these male connections for our cowl. And these are where our collection flasks are going to attach. We'll attach these connection flasks with a Keck clip, just like we did the distillation head. There are different schools of thought about the way that lubricant is used. Some people prefer to use a different name brand of lubricant than the Dow Corning. I just stick with that because that's what the best reviews that I've seen. These don't need to sit on here in any specific direction, just so long as they're on there snug and you've created a good seal. And there will be 3 collection flasks. So when we're doing our distillation, we're going to have a head, a body, and a tail. The head is going to be those molecules that evaporate at lower temperatures. The body is going to be a light colored oil, and the tail is going to be when the light color in the oil starts to turn a darker color. So now we've got this set up. The next piece that we'll add will be this guy, and this will help us just to keep this from falling over. This is a flask holder here, and that looks good there. So here's our next piece that we're going to add. This piece is called a boss head, and this is a retort clamp. So we'll take this clamp and we're going to clamp it onto right here. And I think I'll just lower this guy down to here. And again, you want to just be nice and slow and careful. If it takes you a couple times to set this up your first time, don't feel bad or feel like you need to be in a rush of any kind. The important thing is that you do a good job and be safe and don't do any damage to yourself or to your equipment. Looks like we lost our little holder there. Okay. You don't want a reef on this guy, but you do want it nice and tight so that he's not going to be moving around too much. I'll go ahead and add that piece of cork to the bottom of this guy. And sometimes it takes a little practice to finagle in each piece exactly where it needs to be. And before we actually start our process, we'll make sure that this cow has a nice free swing, that it can swing back and forth. You'll begin with your first reception flask, go into your body, and then do your tail here. So we want to make sure that this apparatus has the ability to swing back and forth. And these are 250 milliliter collection flasks here. And when we're setting this up, we want to make sure that this column is straight up and down. And so the next piece that we can add will be our arm retort here. And again, we've got another one of these boss heads. I'm going to take this guy and use it to hold our cold trap. So the next piece I'm going to connect is going to be my cold trap. Here's my cold trap here. This connection goes to my vacuum pump, and this connection will go to our distillation apparatus. So we're going to turn this guy like so, and this will end up going here. And this little metal dish is to hold our dry ice. So we're going to take that little metal dish and we're going to fill it up full of dry ice. And this little stand just helps to keep it up where it needs to be at the correct height. So I'll just show you what this looks like. So this is the inner part of our cold trap, and basically the vacuum will come out of our distillation set, will come down this tube, and any liquids that might go into your pump and damage your pump are going to stick to the walls of this guy, going to stick to the walls of your cold trap as condensation, and you're going to be pulling cold fresh air from up here on top. So the colder that your pump runs, the more efficient that your pump is going to run. So again, we'll take our Dow Corning vacuum grease and we'll just put a little bit here and make sure that we've got a nice good seal on there. It really doesn't have to be perfect, and I just take the vacuum grease and just do about the top half of the male connection. I never put my vacuum grease on the female connection. That you're looking for a big mess that way. So I'll just gently lower this guy into here, turn it back and forth a couple times, and you can see that it gets this clear look to it. And we're all set there. And then we'll be able to connect our vacuum line here. I like to use a little bit of Teflon tape on the connections. Not so much on the water connections that come in and out here. The cold water is going to come in here and come out here. But at the very top here, we're going to put a thermometer, and I like to use a little bit of Teflon tape on those threads. And right here, this is a vacuum connection, and I like to use a little bit of Teflon tape. The reason why is because we don't want any of our joints to be leaking. We want to get as strong of a pressure as we can from our vacuum pump. So I wrap this connection here with my Teflon tape. When you're using the Teflon tape, you want to wrap it in the opposite direction that the threads go. So now that I've got my Teflon tape on here, I want to very carefully take my vacuum line, and we're going to tighten this guy up as tight as we can without cross-threading it or without damaging that. Okay. And once you've got it tight, you want to give it just a little eighth of a turn to seal that. And here's my thermometer adapter. And you can see that I've wrapped the top of that with the Teflon tape, making sure that keep the Teflon tape out of the hole there. We're going to be using this with our thermometer probe. So we'll start by screwing this cap on part way. And we'll take our thermometer probe and just gently push this in here. And this probe is going to go all the way down into our material, and this is going to give us a digital readout of what our actual temperature is. And this goes down in this here, and this connects around the back. We're going to want to use our Dow Corning vacuum grease again. Every time that we have these glass on glass, we want to use our vacuum grease. If you don't use the vacuum grease, what happens is that you run a risk of the joints seizing together. It's also a good idea to separate these joints. At least, crack them open a little bit while our apparatus is still hot. So when we get done running our material, we're going to loosen up these connections before we allow the whole apparatus to cool off. So we've got our vacuum grease, and we've got our ket clip. Now we'll hold this about down where we want it. We don't have a lot of material this round, so I'm going to put this one almost to the bottom here. And there we go, nice tight seal. Alright, so we have one more piece to go, and that will be our thermometer, and our thermometer is going to go up top here. So the same thing, I'm just going to wrap these threads with a little bit of Teflon tape, and the next thing we'll do is get some cold water and some ice in our bucket here, and we'll be almost ready to get started. So I wrapped some Teflon tape around this top connection here, and now we're going to add our glass thermometer, a 12-inch thermometer, and we'll just put this guy in here, and we want to, I'll show you when I get done screwing this on here real quick. We want the tip of our thermometer to be right here, right where the two pieces come together. and we're going to be recording the temperature right there, and so that's the reason why we're using the long thermometer there. We want it to be exactly where these two pieces of glass meet, and we want to make sure it's nice and snug on here so that we can get a good vacuum seal. This illustrates a little bit better what I'm saying and about having our, and you want to make sure it's where you can read it. Also, as you put this in and out, you want to do it from here and not from back here so that you don't accidentally break your thermometer. So in my pot here, I've got a little pump, and this pump is going to pump the water into our cool water condenser. It's going to come into this connection and out of this connection, and that's just a used fish pump that I found at the local pet store. It was super cheap, I think maybe $10. We're going to take our ice and pour it into here and put some water, and it's important that you put the ice in the water before you plug in the pump. If you plug in the pump dry, it will die, so you want to be careful with that. So there's about 7 pounds of ice, and if I need some more ice throughout the procedure, I can add some more. Now I'll begin adding some water. This is a 2-liter Erlenmeyer flask, and we don't need filtered water or anything like that. Just regular water will be great. The water is not actually going to be touching our material. The water is simply going to be to cool this area. And I'll probably add between 4 and 6 liters of water into my stainless steel bucket here. So I've got my pump plugged in, and I can see that it is this one that is pumping out. So I can go ahead and unplug this for just a second. I've got the one that's pumping out, and this guy will connect here. And you always want the water in to start down at the bottom, and you want the water out to be up here at the top. All the diagrams that you'll see. Distillation, that's the proper setup. You don't need to reef on these, and it's okay if you get a little air bubbles, because again, all we're doing here is cooling. Our steam is going to, our material is going to come up through the distillation apparatus as a steam, and once it reaches the top, this cold chamber is going to cool it back into a liquid, and we'll be able to separate it into different classes or different molecules based on their temperatures at which they evaporate or boil. So I've raised my cold trap up off my dish here. I've got a bag with some dry ice in it here. I'm going to put the dry ice in here and then snuggle this guy down into the dry ice. Okay, I've got my dry ice in my dish here. I'm going to loosen up this cold trap, lower it down in there. That should be just right. Doesn't need to be tight, just enough that we can hold it in place. And that will allow any moisture to condensate within the cold trap, and that will keep us from damaging our pump. And you can see that the line coming off of the cold trap is going to go to our pump, and so I'll show you where our pump is. It's down here in our cupboard. This is for a couple reasons. The first reason is to kind of keep it quiet a little bit, and the second reason is if God forbid it were to explode, it would not hurt me or my distillation set. So we keep that in the cupboard with the door just a crack open, and that's where our vacuum pump is. I'm using a Rocker vacuum pump, a single stage 250. So before we actually run our material, there's one more thing that we need to check, and then I wanted to go over with you just some of the concepts and ideas. I wanted to read from a couple of chemistry books that I have, an explanation of the different types of distillation. So before we can begin our distillation, we need to make sure that our cow here, this is called our cow, and these are our receiving flasks. We want to make sure that this apparatus is able to turn freely, that it's not going to get caught up on anything. That's something that we need to establish now instead of later when it's all under vacuum pressure. So we're going to begin with this first ball here, and we just want to make sure that it's got a free swing so that throughout our process here we can swing this back and forth as need be. So we get this guy up here, and nice and straight. And I'll loosen this one. I'll bring this guy up, and this will be our collection flask for our heads for the beginning of our material. This will be our body, and this will be our tails, just like distilling alcohol. There's a head, a body, and a tails, or a head, a mane, and a tail. So we should be all ready to go. The next thing I'm going to do is put a funnel here, and I'm going to start funneling in my material. So first we'll go over a couple of these scientific explanations of the different types of distillation. And when we're done going over that, then we'll be ready to start running our material. So before we move on to part 2 of our video, I just wanted to go over real quick some of the different terminology and some of the different concepts, not only from an organic chemistry perspective, but also from an alchemical perspective. So I just wanted to go over here, Distillation Basics. This is a really good explanation of distillation. It says, the vaporization of a liquid and condensation of the resulting vapor is the basis of distillation. Organic liquids containing small amounts of impurities or non-volatile substances are easily purified by simple distillation, as are liquid mixtures where the difference in boiling points of the compounds is greater than 70 degrees Celsius. Fractional distillation is more useful for separating mixtures of liquids where the boiling point of the components differ by less than 70 degrees Celsius. A typical simple distillation setup is shown in this figure here. It consists of a flask containing a liquid to be distilled, an adapter to hold the thermometer, and to connect the flask to a water-cooled condenser, and a flask to hold the condensed liquid, or the distillate. And here's our receiving adapter and our receiving flask. So that goes over simple distillation and fractional distillation. Continue on with fractional distillation. The apparatus for a fractional distillation is similar to that for a simple distillation, except that an extension is added to the flask in order to increase the distance traveled by the vapor and the surface area available for condensation. The extension is named a fractioning column and may be open, such as the columns used here, or loosely packed with an inert substance such as glass beads. The purpose of the packing, if present, is to further increase the surface area which the vapor contacts. The length of the column and the type of packing are a large factor in determining the degree of separation that can be achieved with a fractional distillation. Another factor in determining the degree of separation that can be achieved with a fractional distillation is the rate at which the distillation is carried out. The best separations are achieved using a slow, steady distillation rate. A slow distillation rate maximizes the number of vaporizations and condensations in the fractioning column. A really good website to check out for people interested in doing vacuum distillation, fractional distillation, is bestvaluevax.com, and they sell distillation equipment. So here it talks about a vacuum pump. When doing a distillation process, it is imperative that you have a chemically resistant vacuum pump that can achieve extreme depth. The pump should be able to achieve at least 50 micron, but the deeper the better. The preferred type of pump for distillation is a rotary vane oil pump. Rotary vane pumps offer the best vacuum depth compared to other types of pumps. Specialty pumps such as diffusion pumps will be discussed later. Short path distillations can be very chemically abrasive to your vacuum pump. For this reason, it is recommended that you change your oil before every distillation. This will allow the best depth and keep your vacuum pump running at peak performance. And then it talks about a cold trap. The cold trap plays the important role of catching any vapors that pass through the condenser. This protects and prolongs the lifespan of your vacuum systems. It's just like we talked about in our when we were setting up. We talked about how the cold trap will catch any vapors and condense them to the side of the cold trap, and this will protect your pump from overheating. And the colder that your pump runs, the more efficient that your pump is going to run. So the short path system is made up of 4 major glass components and the heating mantle. These components are the boiling flask, the short path head, the receiving cow, and the receiving flasks. The heating mantle is similar to a heat bath on the rotovape. This is how you will heat the mixture inside the boiling flask. The head is the key to distillation. Inside the head there are small indentations called vigoro. These contain contact points for the vapors to bump as they travel up in the head. They create theoretical plates needed for distillation where the vapors will become purified before entering the condenser path. The head also encompasses the condenser where the vapors will be pulled to recondense into that beautiful golden color we all want to see. The 3 receiving flasks correspond to the 3 main fractions. So when we talk about molecular separation, molecular distillation, for an example here I have some phytocannabinoid boiling points, and these are different molecules that are found within a cannabis crude oil. So starting with THC, you can see that the boiling point is 157 degrees. And then the next one is CBD from 160 to 180 degrees. And as you get down the line, these different molecules will all have a different boiling point or a different distillation rate. And so that's how we're able to separate these different molecules. This is a great book that I picked up at Powell's bookstore, Organic Laboratory Techniques, and here on chapter 7 talks about vacuum distillation. The principal difference between a vacuum and an atmospheric distillation setup is that in a vacuum distillation, the system must be airtight and able to hold a vacuum. A vacuum adapter rather than a bent adapter must be used, since this adapter has a standard taper joint connection for a round bottom flask and the tubing connection for a vacuum source. The glassware must be able to withstand the vacuum. For example, large, thin-walled Erlenmeyer flasks cannot be used. Use vacuum grease to seal all glass-to-glass connections. Stopcock grease flows too easily under heat to hold a vacuum. Use only heavy-walled vacuum tubing. Tighten all rubber tubing connections, including the rubber thermometer adapter, by wrapping a wire around the rubber and twisting it with pliers. Assembling the apparatus completely and test for air leaks by applying the vacuum before placing any liquid in the distillation flask. So when we set up our distillation apparatus, one thing that we do before we add our material is we check for any air leaks. Vacuum fraction collectors. If a vacuum adapter and round bottom flask are used, the full run cannot be separated from the main fraction without your stopping the distillation and disassembling the apparatus. Therefore, If more than one fraction is to be collected, a vacuum fraction collector should be used. Two types of vacuum fraction collectors are shown in figure 7.3. So here it shows what a cow looks like. Vacuum adapters and receivers that allow the collection of more than one fraction during the course of a distillation. So in this case, we don't have to turn off the whole distillation in order to be able to just swing this cow to the next receiving flask. And this kind of goes on in a little more detail, but that's the basic gist of it. And finally, I wanted to talk about distillation from an alchemical perspective. So this is a book by Frater Dennis William Houck, FRC, and here he talks about the distillation process from a Rosicrucian and from an alchemical perspective. Distillation is the boiling and condensing of a solution to increase its concentration and purity. The alchemists believed that distillation released the pure essence or spirit of a substance in the evaporating vapors. For example, one can obtain the pure alcohol spirit of wine by distilling a solution of fermented grapes. The essence could be concentrating using a process known as rectification. And here he gives a definition of rectification. Rectification is the process of refining or purifying a substance by repeated distillation. The evaporated distillate is returned to the boiling vessel to be distilled again. Continued cycles of distillation eventually produce a thick and extremely concentrated solution the alchemists called the mother of the stone. A typical distillation apparatus consists of a lower boiling vessel, or the cucurbit, and an upper stillhead, or the alembic, which is a hooded vessel that collects the rising vapors. The hot vapors are cooled in a long condenser, and the purified condensed liquid, or the distillate, is directed by a tube or funnel into a receiving vessel. A popular medieval distillation device was nicknamed the pelican. It was a glass retort, a type of container with two tubes connecting the neck of the vessel with the lower body. Distillation is the most important operation in practical alchemy, and some alchemists spent months distilling the same solution over and over. Distillation is described in the Emerald Tablet in these words: "It rises from the earth to heaven and descends again to earth, thereby containing within itself the powers of both the above and the below." The alchemists chose the astrological earth sign of Virgo as the cipher to signify distillation. The Egyptians associated the alchemical goddess Isis with this sign. The cipher for the operation of sublimation was Libra, an astrological air sign the Egyptians associated with the divine child, as well as Mat, the goddess of truth. Two-headed creatures are shown rising into the air on wings and then returning to the earth in drawings depicting the distillation process. The repeated circulation between the spiritual forces above and the material forces below eventually led to a concentration and purification of the essences of the substance at hand. And here we see this rebus, and this is an illustration, like a woodcut illustration from an ancient alchemical text. And this basically speaks to the above and the below, this alchemical concept from the Emerald Tablet of Hermes, where Hermes talks about as above, so below. So this is a very important Hermetic axiom. So these are some of the different explanations and concepts associated with our project for today. And our next video, we're going to get into the actual process of distillation. I've got some crude oil material that we're going to be running, and so please check back with me soon. Thanks again for checking out the video. If you want to like, share, and subscribe, that'd be really great. And stay tuned. We'll have part 2 where we're going to run our material, and we'll do part 3 where we're going to do a final cleanup. So thanks again for watching. Peace profound, and L.V.X.